Exercise 3.5, the rational root theorem. The values of x for which p of x is equal to 0 are called the zeros or roots of the polynomial of this equation. So they're the solutions. We can make use of the remainder and factor theorems to find the roots of polynomials. And what it's really about is just using a process of trial and error. We substitute different numbers into the polynomial and see which one produces a 0. Therefore, we've established a root from which we can identify what the factor is, or the linear factor is, of that polynomial. The basis of this is that it's trial and error. If one of the factors is something like x minus 1, x minus 2, x minus 3, or the positive versions of that, then the process is really simple. But that's not always going to be the case. Most of the time it will be, but sometimes it may not. As an example, if we have factors that involve fractions, then obviously you're never going to be able to guess what that fraction is. So with the rational root theorem, it's really just a way of establishing a set of factors that we should, a set of possible roots that we should explore. Let's consider this polynomial. The coefficient of the highest term is referred to as being q, and the constant at the end is referred to as being p. Please note, in my notes I've got this messed about, and can you put that little arrow in there to make it very clear? Here's our steps. I'll let you read that. It's easy to see in the example. F of x is equal to this particular cubic, and I want to try and factorize it, or create a list of roots that could help me out in factorizing it. Firstly, I identify the constant at the end here, which is -6. So what I'm saying is that p is 6. So I just ignore that negative sign because I take into account the possibilities of being positive or negative at the end. So the factors of this 6 are obviously 1, 2, 3, and 6. The coefficient of the highest term is 4. Factors of this 4 are 1, 2, and 4. Possible roots that I should explore to be able to produce the factors of this f of x are shown below. They are plus or minus the factors of p over the factors of q. So we create this long list of all the possibilities that can be created from these factors. So I begin with having factors of p. So I'm looking at 1 over 1, 2 over 1, 3 over 1, 6 over 1. I now look at the factors of p over 2. So 1 on 2, 2 on 2, 3 on 2, 6 on 2, and they're shown here. And finally, I put all the factors of p over 4. So 1 on 4, 2 on 4, 3 on 4, 6 on 4. And I've got the positive and negative versions here. Simplifying everything, these are my list of possible roots that I'm looking at. So what I should be able to do now is substitute all of these different versions in and then come up with what the linear factors are. So in some ways, it's still going to be a process of trial and error, but what we've done is that we've reduced the possibilities that we should explore. Problem 2, exactly the same thing. So my constant at the end is 4. Factors are 1, 2, 4. The coefficient I have of the highest power is 3. So the factors are 1 and 3. And now I look at the possibilities, and you can see we can create this list here.